Here we see all of the different supported products of control that we have. We do relays, leading and trailing edge dimming. We do 0 to 10 volt, DSI, Dali broadcast. We do Dali enumerated with feedback, the difference being that we can check lamp status. We have BMS integration. We have native LOM product where we can talk to up to 32 areas or zones in 2 directions. And we have various backnet devices. Our base level device we can do 200 points. The mid-tier device 600 points. And using what we call a soft JACE application, we can go up to many thousands of points. Most of our products can also support DMX512. We can receive DMX512 on a lot of our controllers, and we also have a gateway product where we can receive and then tell our lighting system to do particular things. The gateway can also act as a DMX512 transmitter, which is ideal for when we are trying to adopt RGB, LEDs and other entertainment type products as part of an architectural lighting application. Let's look at some of the other product specifics. The service LED has 3 signalling modes. Blinking at its normal mode is 1 Hz. This means normal operation and no network activity. The minute we trigger a sensor or push a button on a panel, we broadcast a message. We could expect the LED to start blinking fast, or at 4 Hz. This shows the network activity is detected. If the LED is on all of the time, there is some form of fault. Likewise, if it is off, there could also be a fault. It should not just be assumed that there is no power. Always double check. The service switch has a few different operations. If we do 1 push, the device transmits its network ID. By default, it will transmit its device code and its box number out onto our software applications. When we do this with most of our software applications, the device will then get polled for its serial number, and that's typically how we start commissioning some of our devices. If we use that push button to press it 3 times, it will send all of our channels to 100%. This is a great feature because if you have a catastrophic network failure and you had to get some lights on, you can still go around to all of the individual load controller products and do 3 pushes, which will override and turn all of the channels onto 100%. If you push and hold the button for 4 seconds, it will perform a reboot. One of the more important functions on an enumerated Dali controller, if you do 4 pushes, it does what we call a 15-minute Dali broadcast walk test sequence. This is a very useful function for contractors to ensure that they have Dali connectivity to all of their fittings. What this means is once the whole system is wired up, they can press the button 4 times and then through a period of 15 minutes, the lights will cycle between 100%, 80%, 60%, 40%, 20% and off. This enables the contractor to walk around and make sure that he has got Dali connectivity to every luminaire. The auxiliary input on the load controllers is not used in a lot of applications, but it can be used as a dry contact, low-level interface with a max 2 meter run-through. Low-level means it's a simplistic interface with only 2 states, on, off, or open and closed. It can be used for an emergency light trigger or local security interface if you wanted to. In the case of security, that dry contact is between AUX and ground and is an active load. When you put a short circuit between the ground and AUX terminal, that's the active state of that input. It is fully programmable within the controller, so you can program it to do various tasks. Most importantly, make sure the cable length between this input is no longer than 2 meters and make sure you keep it clear of any mains cabling. This will go straight into the microcontroller port, so it's very prone to noise pickup. This is particularly applicable when we are talking about any of our dimming products. Not so much with our contactor or ballast control products. If we're talking leading edge or trailing edge products, these products produce some heat as part of their dimming function. So 1% or less of the energy on each circuit is lost through the chokes and the semiconductors, so they will generate some heat. That being the case, make sure you follow this diagram as far as minimum gaps to make sure that the rising heat does not cook cabling, and particularly that you don't put the devices close to each other and create too much excessive heat build-up, because you will cause premature failure of the products. DIN-rail devices. These devices are the majority of what we put in most installations these days. They are small and compact and they are easy to implement. The marketplace has been changing away from incandescent loads to LED and fluorescent loads. These are the predominant controllers that we use. A number of devices are available in the DIN rail form factor. Load controllers, time clocks, power supplies, gateways and dry contact interfaces for low-level integration. With the DIN rail devices, they should be installed into a proper electrical enclosure. They always require an external circuit breaker protection. It's not part of the controller, unlike the wall-mounted devices, although in saying that, the wall-mounted devices should always be protected with the appropriate circuit breaker. All the DIN rail mounted load controllers have fuses on their sub-circuit. This is native to the Philips Dynalite design, which does enable us in residential applications to drop the cable size. So if we look at typical products such as DDMC 802, it has a 16 amps supply circuit to it, but each output is fused at 6.3 amps, enabling us to drop to 1 mil cables for residential type applications. This is not applicable in commercial applications because you cannot use 1 mil cable. The DIN rail controllers are the more economical option, but then you have to add the additional housing. More importantly, because we now have power and data fairly close to each other, you have to spend a lot of time making sure you abide by correct cabling practices. Make sure you have the correct segregation between the mains power cable and the data terminations. Data cabling on all of these controllers is always terminated at the bottom, and any of the products that has mains cabling is terminated at the top. So bottom of the controller for data, top for mains. All data cable that runs within the electrical enclosure must be mains rated for safety. That means that the installation properties of the cable must be a minimum of 240 volt rating. The orange Dynalite cables that are supplied through Philips Dynalite do have the appropriate installation ratings. Our panels can be mounted in a wall box available in lots of different configurations and can be mounted vertically or horizontally. Primarily, these panels are designed to be vertically mounted, mainly because the buttons have been designed for engraving horizontally. Out of the factory, there are some default presets that are programmed. All devices that come from the factory are always configured with what we call Area 1. What this means is that because all raw products that come to you from the factory are pre-commissioned at Area 1, it means that the system will natively work without any commissioning. This is great for testing. Press button 1 on a panel, which will be set to preset 1 Area 1, and all of the lights will go to preset 1, which by default is 100%. Button 4 is always preset for Area 1 by default from the factory, which is 0%. So you can press that button and all of the lights will go to 0%. If we need to identify any of our panels, we can hold down a button for 10 seconds and it will sign onto our software application and identify itself. This diagram shows a DR2P panel, single column in the AU or NA format. As you can see, the front fascia clips off. Each one of the buttons can be replaced, so particularly if you have done an installation and you need to replace a button with engraved ones, you can. Most importantly, on the bottom right there is a socket where you can plug in a programming probe. This is great because it enables any of the field panels to become a network access point for configuration to the system. It makes it very, very easy to plug into the system wherever you like. We have a number of different sensors. Occupancy using passive infrared, now also ultrasonic. All of the sensors are tertiary sensors, which means that they can do occupancy, PE and infrared receive in all the one sensor. Our historical sensor is the wall-mounted sensor, which is the DUS704W, the W meaning for wall. It is an analog sensor where we can adjust the sensitivity of the sensor. It has built-in PE functionality, PIR occupancy and IR receive. If we go the next sensor down, we have the DUS804C, which again does all three, PIR occupancy, photosense and IR receive. Note the photosensor is kept away from the passive infrared. This is to make sure that LED, when it sees infrared, doesn't interfere with the LED feedback part of the sensor, particularly when you are doing daylight harvesting. This sensor also has an integrated motion shield. So if you have a doorway close by that you want to shield away from occupancy sense, You can rotate the sensor around as part of the installation and drop the shield to make sure that you have a blind spot, so not to pick up passing traffic. This is a very, very useful function. This particular sensor uses a digital sensor, so it purely sees motion or not. This makes it very, very easy to configure, but the sensitivity of it is very, very high. Our newest sensor is the DUS 804 ultrasonic. On the occupancy side, it is what we call a dual sensor, so it has passive infrared component as well as the ultrasonic component. The way these sensors should be set up for commissioning is to use a passive infrared for the initial sense of motion. Then once you have sensed motion, you engage the ultrasonic to then look for fine motion. It's important to note that when you are utilising ultrasonic sensors, you can't have more than one in a single space because it will cross-interfere with each other. Effectively, one will trigger off the other. If we have a large open plan space, we might have an 804C on the entry and exits, and then an ultrasonic mounted in the middle of that open plan. So as soon as we see an entry of the open plan space, the 804 will trigger the lights on, and the PIR or the ultrasonic component of the centrally mounted 804C ultrasonic sensor will then pick up any fine motion to stop the lights falsely turning off when there is only one person occupying. These are your typical lens patterns. Let's have a look at the DUS 704W. The passive infrared puts out fingers of IR beam and requires a heated body to cross over those beams to get the reflection back and to sense the motion. The further that you are away from the sensor, the wider those fingers get, and that means more substantial movement is required. With the ultrasonic, it has some high coverage ranges as shown by the diagram. It's important to understand and to not put the two of them too close together as stated previously. With the ultrasonic, it has some high coverage ranges as shown by the diagram. It's very important to understand and to not put two of them too close together as stated previously. Here are some more typical lens patterns for our other sensors of the DUS 804C and SM. The SM stands for slight motion. The lens pattern, you can see there are more beams and they are closer together, so there is more chance to detect movement. This is good for small cells and offices or higher mount ceilings. The footprint of each of these is different also, so it's important to check the datasheet when you're installing these devices to see if it's a circular footprint or a rectangle. If it's a rectangle, then you can check the axis of the rectangle by looking at the face of the sensor, and there is an arrow imprint on the front of the sensor which indicates the length of the rectangle. The most critical thing with sensors is location, location, location. These two diagrams show the correct installation and incorrect version. Looking at this diagram, we could even improve on the correct version and move the sensor to the bottom left-hand side of the room. If we look at the sensor on the left-hand side, it's located almost straight over the desk where the person would normally be sitting. So what will happen when this person walks into this room? They will be walking into the room parallel to the beams coming out from the sensor. So the likelihood of crossing over the beams means they won't be picked up that well. What will get picked up fantastically is anyone walking past that office. They will be crossing the beams over, so you will get a lot of false triggers from corridor traffic. More importantly, when someone is sitting at the desk, they will be sitting with not much movement, and the likelihood of the sensor turning off is pretty high. With the next diagram, if the sensor was located down here in the bottom left, any walking traffic in the corridor will not trigger the sensor. When you walk into the office, you are going to cross straight over the beam, so it will pick you up every time. And more importantly, you are some distance away and it will probably pick up motion quite well if you're sitting there working away at your desk. A lot of design documentation will show the sensor in the middle of the room, but it is important to know from an installation point of view where it should be located. If the sensor has already been installed in the middle of the room, make sure you use the drop-down shield and pull it down to mask the corridor traffic. Make sure that you haven't got bright light hitting the touchscreens, as it will obviously wash out the displays. The DTP100 must be flush mounted. The DTP100 is the smaller screen here. The DTP touchscreens run Windows CE. Depending on the programming, they can be utilised to browse the web or incorporate RSS feeds, so we strongly recommend that when you are allowing for these touchscreens, as well as the Dynalite cable, make sure that you allow for an additional twin active for the power supply, Ensure that you allow for twin active that goes back to your Ethernet switch to allow for internet or routing capabilities. The 170 is designed to be flush mounted. Both of these touchscreens have inbuilt speakers and microphones, and they can be interfaced with third-party intercom systems to become part of an intercom system as well as work as native Philips Dynalite panel and controller.